need the SQL. So when you submit SQL to access the data, first it will scan, parse, and validate it. During the scan, it will check the keyword and word by word, and check your syntax of your SQL. Then validating means the validate whether you have the permission or not. Okay, after this step is completed, and Query Optimizer will decide the plan. We don't know how to make the plan, we will see today, but we know right now there might be a bunch of different steps because for example selection there are 9 different ways. Also for join, there is a nested loop join, sort-merge join, and single loop join, and hash join. 4 different ways. Each company, each vendor has a variation or variety of join also. So also there is a different order of table that you are going to access. Sometimes when you join 3 tables, there will be more than 2,000 different cases. Then how can we decide the best way, fastest way for the execution plan? So there are 2 ways. One is cost-based optimizer. Second is rule-based optimizer. Rule-based optimizer, we will have the rule. Like I'm going to use fly if available. Next priority is train. Last one is working. So which one? So if available from the top priority, you will select. Just like that, if we have the primary key, even though primary key is not the best way, primary key will be selected to access the data. That is a rule-based optimizer. On the other hand, cost-based optimizer will compute the cost each and every case. That's the problem. Okay? We don't know how to compute the cost regarding to the cost function. That is summarized in this handout we will see today and the next week. But once we have such a cost for each case, it takes a longer time to compute each and every case cost, 2,000 cases. Okay? So we need to minimize, narrow down the cases. That is a heuristic. So today's lecture will start from the heuristic approach of the query processing. Okay. So using heuristic in query optimizer, this is a process of the heuristic optimization. First, the parser of the high-level language generate an initial internal representation. How? Query tree or query graph. So query tree is like this one. We can make the tree based on what? Relational algebra. So why don't you take a look at the example of this query. Probably we have seen the example of query in both in relational algebra and SQL part. Okay, so this is a relational algebra expression. First we are first in SQL, so we are going to join 1, 2, 3 table. There are 2 join condition and the 1 select condition, and retrieve the project this column. So this is a little bit distorted, but you can understand the 2 join condition and 1 select condition. Okay, then project this number. We are going to decompose this one using the tree. This is an initial representation of your query. So, for example, in this case, the node represents the table, and if you have the select condition, you can specify the select condition, and also if you have the 2 branches, you can join. Okay, then finally you will get the data. Is this the only way to access? So you can start from project. Project, select the step 4. Okay, that's satisfied with this one. Then join with the department with the join condition, and join with the employee and join condition. Then finally you can project. Then you will get the output that you expect from this SQL. Okay? Is that the only one? There are a bunch of other ways actually. So another example of the alternative way to access the same data is you can do Cartesian product or project, department, and employee. Okay? Then apply the condition, select condition, 2 join condition as well as the select condition. Then will be returned. Then apply the project. Are they same or not? In terms of output, it's the same. Okay? In terms of performance, it's a totally different. Okay, so first you will get such an initial representation of the query in terms of a query tree. That is called a query tree. There's another way of representation of query, that is a query graph. Query graph, the difference between query graph and query tree is the same as difference between tree structure and graph structure. In tree structure, there is a direction, like the parents and children. So you are going to start from the leaf node and going upward. In graph structure, there is no direction, but it shows the relationship between P and D. What is the relationship? It's a join. And the D and E is a join with a join condition, and this is a select condition. There is a relationship between this select condition. So finally, you can get the data. But mostly, query trees is used for query optimization. Okay? So first step is we will get such a query tree. Then apply the heuristic rule. This is our objective, to optimize the internal representation. Optimize. What is the optimizing in terms of query optimization? What does that mean, optimizing in query? Different output? No, output is the same. Okay? So cost, time, how long it takes. Okay? Optimization means optimizing your execution time. Okay? So how can you optimize? The simple idea is, do you want to keep all the data at the beginning to the last? If you keep all the data, it requires memory space also. Also, it requires more I/O, input and output. So it takes longer time. Why don't you take a look at these two typical examples? So to perform, if you implement the query processor for this one, and also if you implement the query processor for this one, first, in this case, you are going to use, in the memory, probably you will select the row tuple that satisfies with the Stratford. Let's say that is only one project, among 100. And department, you are going to join this project and department with this condition. You have the 10 department. Only one department has a project of this one. Only one data return. Employee who works for this one, manager, social manager, will be how many employee? 1 million employee, and only one will be returned. Then project this one. Okay. On the other hand, what about this? You are going to Cartesian project. How many projects? 100 times 10 department time 1 million. How many? 1,000 million. Trillion. Will be joined, combined. Then how many attributes? How many columns? Plus, plus, plus. Okay, all column for 1,000 millions data. Then finally apply these two conditions. Right? Which one will be better? Definitely this one is better. Everybody knows that. It's obvious. Okay? Then heuristic rule is, if you can minimize, narrow down the output, apply as early as possible. In other words, move down such a selection condition, like a Stafford. It's a very strong condition to narrow down the data. Only project that is in Stafford will be used in our query. We don't have to keep all the others, right? Also, consequently, department that is not related to Stafford will not be considered. Employees who are not in this project, especially manager, will not be considered. So roll out as soon as possible. Then it will speed up, obviously. So that is the idea of heuristic. Okay? So that is heuristic. So apply heuristic rule. That heuristic rule will minimize, okay, reduce the research. So query execution plan will generate the executor group. Okay. So then, what can be the heuristic rule? There is details of the rule letter from 1 to 6 and more than that in real DBMS system, but simply we can summarize that is the main heuristic is apply first the operation that reduce the size of intermediate region, right? That makes sense. Apply first. If you can minimize, reduce more percent, 99% will be eliminate, ruled out. That will be the first. Then next, okay? Perform select as early as possible, right? Select is pick up only certain limited, restricted data. So we don't have to keep that. Apply select as early as possible. What about the projection? Projection, if some attributes are needed in your query, apply the projection as early as possible. Okay? These are the heuristic rule. So it's but it can be described formally like this way. So there is the transformation rule to handle relational algebra. Relational algebra, okay, is from the mathematics. It's a set theory. So to handle such a relational algebra operation, we need to certain rule. All of this you already know. Okay? For example, commutative, you can change it, right? It's not complicated. And also the cascade rule, you can separate for each the condition, logical condition, also cascade rule of the projection, and all of this you already know. By applying this transformation rule, you can actually implement this one in your database engine, not your query. Okay? If you are assigned the team who developed the DBMS system, then at the time you can apply this. But idea is, as a database administrator or as a designer, you'd better understand only this summary. Apply the operation that can minimize more as soon as possible. Also selection as soon as possible. Attribute as soon as possible. So let's take a look at the example of this. Okay, so this is the heuristic operation optimization of query. Okay, I think this is employee last name. Project name is Paris, and birthday is like that. And these are the join condition. If we make the initial, okay, this is the simplest way. Actually, when I ask a question, I didn't actually mention about this one. Any, okay, almost any the relational algebra expression. You can simplify Cartesian product, Cartesian product, Cartesian product, everything, then apply selection and projection later. That will be fine. Nobody did. Okay? But that may be problem in terms of performance. So that's the reason I do not suggest to use such a thing. But this is the simplest way to make the relational algebra expression. So database engine will start from this simple thing. Then apply the heuristic rule. For example, in selection. So any selection part, so birth date and project name apply for each here. Okay, move down. Then, and in this case, project and works one, because number of project is xrays, 1. But what about the employee? We don't know how many employees will work for that project. It can be 1 million. But in terms of this one, if P name is the primary key, even you are sure this is only one data. So which one is better in terms of heuristic rule? This one, project or the employee for the first operation. Definitely project, because it returned only one day. Because that is the reason change the position, the project, okay, with the employee. Okay. And what about this one? Project works on employee. So this is a Cartesian product. So we can combine with Cartesian product with this one. Cartesian product with this one for joint operation. So this is with the joint operation. Okay. Then next, heuristic rule is project even. For the project, we don't need all attribute of the project. Instead, P number is enough. P number will be used for join. Okay, piano is used for join, and the social security last name is needed because output should be last name. So apply the projection operation, project operation to minimize the output intermediate project. Then that's the final. That's the heuristic rule. Okay, even heuristic rule can suggest the optimal path. It's not best way. Why? We don't know actually how many this project or this operation will be used until we know the statistical information about the data. We can just guess, but we are not sure. Okay, this is nothing but the rough guess. However, using this rough guess, we can minimize bunch of cases. Okay, we don't have to compute 2,000 cases. Instead, we can minimize. So that is the major rule of heuristic operation. Okay. Then finally, we can make the query execution plan. Okay. So, because of the limitation of the heuristic operation cannot be used in entire query optimizer. However, heuristic operation can be used for to minimize the cases. So let's say we have the 10 cases, 10 different routes. So in other words, when we travel to Manhattan from Bridgeport, our heuristic rule is we will eliminate the longer than 3 hours. Okay? So, for example, what will be the bicycle? Bike will be longer than 3 hours, automatically removed. Okay? After we rule out several cases, we have 5 different routes to go to Manhattan. At that time, we will investigate how long it will take details. Okay? Fine detail guess. That is cost-based query optimization. Then we mentioned about a lot of time cost. Cost can be measured by what? Time. How can you measure the time? So what?
Based on previous executions.
Which one is the most expensive operation on the computer? I/O. So we will count input and output. I/O only. What about the other? That doesn't mean query, doesn't mean other operation. Yes, we need memory, we need the I/O in the CPU register, and burst speed, and latency, thick latency, but we can ignore. Why? The disk I/O is the most expensive. Take a longer time than any other operation. So we are going to measure this cost by counting number of I/O. Actually not counting, guessing, estimating I/O. How can we guess? How can we estimate using statistical information? The best way is you can ask your friend. You can ask your friend, why don't you take the train? Then let me know how long it takes. Why don't you drive? And let me know. Why don't you work? to the Manhattan and let me know. That's the best way, but it takes much longer time and expensive. I need to pay the flight and everything to find the best way. That doesn't make sense. So it will be definitely gas estimation. Based on what? Statistics. So we, for example, when you are asked to find the best route to visit the Manhattan, you probably use the Google, right? And you visit the MTA website and the schedule, check everything. That's the same thing. So we will collect as much information as possible, okay? Especially in the database, that is a statistical information of your table, okay? Without them, no matter what types of, how expensive query optimizer you use, no, that doesn't work. So that's a very important. That is the reason not many database administrators actually realize the importance of the refresh your statistical information. So when you launch your system, it works fine, very well. So you're the project team or the third party who developed this one and transfer this system for the real. Then it works, but a year later, nobody pay attention to such a refreshing your statistical information because at that time, during that time, your system is larger and larger and larger. Some of the data are garbage. So without refreshing, so your query optimizer will not work very well. So that means your query will be slow and slow. So today we are going to see such a cost function, how to measure the cost. We will see how to refresh, how to get the enough statistical information from the database during the exercise lab. Okay? So, as you can see, there are different criteria of the cost, access, storage, whatever, but we will consider the number of IO. So to do that, we should understand the notation that we are going to use. First, IO can be represented by the block. So that is the reason number of blocks in a table is very important. I don't have to explain again what is a blocking. Okay? So instead of number of record, we are going to count the number of blocks for host. Okay? And record size R and number of record R. Why do we need this one? In case we have 512 byte block size. Okay? No matter what size, no matter. Even though you have the 10 byte record, you need entire block. Okay? Also, when you collect the statistical information about your table, are you going to count how many rows in your table? Do you need to count all of them? No. Sometimes if you are using the flexible record, not fixed record, some of the record is 10 bytes, some of the others are 20 bytes, we don't know. So we need to statistical data. For example, average. For example, record size I means is the average record size of employee. Okay, for example, it is 10 bytes. And how many records? It's also sampling. It's based on the sampling. So we can collect such information 500. How many blocks do we need? 500 tuples and 10 byte record size. How many blocks do we use? At that time, first we need to compute the blocking factor. Blocking factor means average number of the records in one block. In this case, how many records can you keep in one block? 51. Okay? 10 bytes, 10 bytes, 10 bytes, 10 bytes. How many? Up to 51 records. So at that time we are saying blocking factor of this table is 51, which means average, on average, 51 records will stay in one block. Okay? In other words, if you have 500 records, how many blocks? How many? 10? 11. 10, it will be, 10 is enough because of 51, right? 10 blocks. So you need a 10 blocks to keep all 500 tuples. Okay, that is the notation. So small r represents the number of records, and large R is the average record size, and number of blocks is B for the table, and blocking factor is average number of record in one block. That is the most important factor in database. Okay, then also we need information about the index. That is the number of level X. What is the number of level? In case of B2 index, it's like that. How many IO do you need? 1, 2, 3, 4, something like that. So level is important. So this is a bet. How many level? X. In this case, X equal to 3. Number of first level index block, which means this one. Why this is important? In case you have range query using primary key, you can use sibling pointer. How many number of first? You don't have to up and down to access the data in B plus 3. So that is the number of PL1. Okay, number with distinct value. What does it mean? Number with distinct value in index. If you have primary index, primary key index, or secondary key index, how many index key entries do you have? It's the same as number of record. It's a dense index, also unique. So at the time, that is the number of distinct value is the same as R. However, when you have clustering index, like a department, so for employee, you have 1 million of employees, but you have department, 10 different departments. At that time, if you create the clustering index, you have only 10 distinct values, not 1 million. Okay, for index. So that's the distinct value. Selectivity means, okay, department number 1, 2, we have less than 3. Okay, so we have not 1 million, 10 employees. We have 3 departments. There are 2 employees who belong to 1 department. 3 employees for number 2 department, 5 for number 3 department. Let's say. Suppose that we have 10 employees with the 3 departments. Department number 1 has 2 employees. Department number 2 has 3 employees. And the department number 3 has 5 employees. At that time, selectivity is the percentile of this index. How many? 20%. How many? 30%. How many? 50%. Then, selection cardinality is how many? Actually low. 20% selectivity times record. How many record? 10. So 2. How many record? 3. How many record? 5. Somebody may be curious. Why do you need to multiply this one? Because all of this information are based on what? Sampling base. Not counting each and every case. Okay, we will see later during the exercise. So this is based on the sampling, so we need to guess, such as selectivity and selection cardinality. Why this one is important? For example, I have index for department number 5. So my query is to select from employee where D NO is equal to 3. Okay? Many people believe using index is faster than full table stack, linear search, right? So I decide to use the index. Index 1, 2, 3, then go to table 4. Then how many employed? 50% of employed. We need to access this one, this one, this one, this one, this one. Right? What about the full table stack? You can just access this table only. Okay? Roughly half of them are selected because of selective selection cardinality. We don't have to use the index. Okay, this one is faster. To measure such cases, so we are going to use the selectivity and selection cardinality. Usually, not every time, usually selectivity is, when you are using the index, the selectivity should be less than 20%. Okay? If your query has the selectivity higher than 20% for the specific attribute, using accessing through the index is slower than linear search. Linear search is fast. So this is common mistake. The index is always a faster way? No, not always. You need to consider such a, if you do not understand such a query processing, that means it's hard to understand why index usually is faster. No, not always. Okay, depending on the statistics of your table. Okay? So using this notation, we are going to compute the cost from mostly select and join operation. Okay? Especially join operation is probably I mentioned many times. Join operation is one of the expensive operation in database. We will see how much expensive. So before that, so linear search. Okay? So BFR blocking factor, what is X, these are explained here. Okay? You should keep your mind. Or handout. Handout from the top, you will see the notation. This is, we are going to use this notation first. Linear search, in other words, brute force approach. In Oracle, they say it's a full table step. Doesn't matter, it's the same meaning. Then what is the cost? If you access all the table, it's a B. What does it mean, B? Number of blocks, okay? Not number of record. Nobody uses it in the database. The by num record, it's a by block, okay? So number of block. However, on average, it will be half of them, especially when you search only one data. Okay, if you are lucky, you can get the data from first block. If you are not lucky, it will be end of block. On average, it's a B over 2 in half, right? So that is the reason B over 2 if the record is found. Otherwise, you need to keep going. So especially when you access only one data, how do I know whether this is one data, one or the many? If that column attribute is the primary key or the unique key or secondary key, definitely is 1. Otherwise, you need to consider B. Okay? Okay. Make sense? So, that's it. You did one cost function. Second cost function is for binary search. What is the binary search anyway? What is the binary search?
Making it into two parts and
Cut it in half. Whether bigger, smaller. Then move to that. And cut it in half. Cut it in half. So, computational. In terms of bigger notational, complexity, computational complexity. Yes, computational complexity is log b based on 2, right? It's a logarithm function. So what does that mean? B is the number of blocks. So what is the linear search? It's like this. Which one is better? This is the number of B. The more block you have, the longer time, because it's a linear. Log B is like this, huge difference. So this one is much faster. However, we can use the binary search in case what? N order sorting data. Okay? So log B based on 2. What is this? Actually, this one is like that. What is S? S is the selection coordinate. How many data will be written? We are not sure whether this attribute, for example, select from where employee, the manager social security number is 111, whether this column is unique or not. So in case of unique, we don't need this part. It's always log log B based on 2, cardinal half, cardinal half. Finally, eventually you will find the data. What about the select? Inequality, range query. From this point, you need to read entire data. That's bigger than this, or less than this, or even range. That is number of. You don't have to read all of that. Instead, read this amount of record. Who will read? That is selection cardinal. That's the reason we need that information. That is a flowing. Okay. No matter how many bars do you read, at least that block will be read. Okay. That is the reason. Flowing minus 1. Okay. In case it's a unique, actually we don't need this part. Because using binary search, eventually you will find the data. In case range query, from that point you need to read entire data within selection cardinality. Okay? So that is the S over blocking factor, flooring minus 1. Okay. The next is the primary index. This is a primary index or hash index. Primary index is that's a multi-level index, which means how many? 1, 2, then data block. 1, 2, data block. 1, 2, data block. Right? Always plus 1. What? Level of index plus 1 you need to access the data. That's the reason X plus 1. However, in case of hashing, so hashing is a little bit different. In case of hashing, you need to put all the data one of the hash bucket based on hash key function, right? So this hash bucket is usually less than within a block. So that's the reason only 1. However, sometimes it can be, it will take a longer time. So it's not always 1, just we will consider hash is 1. If that is 1, that is the fastest. So do not pay attention too much for the hash. The next one is index to retrieve multiple records, range query. In this case, it's a range query. Okay? So, using index, how long it takes? Number of level, right? Always number of level. Plus, because it's a range query, from that pointer data block, you need to read all the data if you are lucky. If you are not lucky. If you are lucky, is less than that. On average, so B over 2. That's the reason. Because cost function is not exact function. It's an estimation, but for best. Okay? Then, cluster index to retrieve the multiple record. So definitely we need this one. Right? Then we should know selection cardinality, just like the previous case. Okay? Selection cardinality, how many? The block divided by blocking factor. Blocking factor, sorry. Then, this is most common index, B plus 3 index. We can make the apply the B plus 3 index any attribute. It doesn't matter whether the primary key, secondary key, or the ordered table, non-ordered table, cluster table. So that's the reason this is most popular. More than 90% of the real index is based on the B plus 3 index. What is the complexity? It's just a simple. Okay? Level plus selection cardinal. How many rows you have? We don't know because the data is not sorted. So, for example, select from where manager social security number is 111 who make the B plus 3 for this one. This 111 will be everywhere. It can be everywhere. So that's the reason it's based on the selection cardinality. We need this amount of ion needed. Okay? So in case this is an equality condition, but what if this is the primary key, SSN? At the time, selection cardinality is 1. Only one data will be written for primary key attribute. Right? That's possible. That is the reason I mentioned many times when we wrote the index. Always 1, 2, 3 plus 1. 1, 2, 3, 4 plus 1. That means the x plus s, x plus 1 in case of equality. In inequality case, it will be range query. What does that mean? This one. B1, BL1. L means leaf node. Why don't you take a look at the notation?
Number of first block.
Number of first row block. That means how many leaf block in B plus 3 index. Do you remember? In B plus 3, this is the leaf block, right? Why do we need to count the leaf block? This is a range query. Okay? In case of range query, we don't have to be up and down. Instead, we can read sibling node, sibling pointer. How many sibling nodes? DL1. We don't have to read all of them. If we allocate sometimes one block, sometimes all of them. On average, divide by 2. Okay? That is the reason DL1 divided by 2 on average. Then R2 means is the data block. You need to access for each data block. On average, half of the record you need to read. Okay? So that means even though you create the primary key, okay? However, if you are using the range query like the inequality, we cannot guarantee the performance. It will take much longer time than you expect. That's why is in terms of relational model, the best performance will be from what? Okay, so we will see. Okay, come in.